Hi, and welcome once again. A reminder that all the programs I show in the video have links in the description which you could open to understand the topic better. And I hope you've subscribed. In this video, we're going to look at execution of a program. Then we look at different types of errors such as syntax errors, runtime errors, and logical errors. And in the end, we'll do some error handling. A program is a collection of instructions that can be executed by a computer to perform a specific task. Now, this is written in any programming language and it's executed with the help of a compiler or an interpreter. So when we write a program in any editor and save it like a file, we can actually use that code over and over again. Execution is the process by which a computer executes the instructions of a computer program, and these are simply commands or program instructions which are chained together. So what happens when a file is executed? The operating system loads the program from storage, and if there are some libraries or modules in the program, then the operating system loads these to make the program work. An executable file is created, and that is used to perform various functions or operations according to the program. Now, unlike a data file, an executable file cannot be read because it's compiled. We're now going to look at the execution of a program in Python code. Suppose we've written a program in any Python environment, we've saved this file and we run it. The syntax checker and translator checks for errors. In case there are any found, it outputs the syntax errors. Otherwise, it translates to bytecode, and bytecode is executed on Python virtual machine, which outputs errors during execution. In case there are no errors, it will give us the output. Let us see this in an example which has a recursive function to generate the Fibonacci series, and we will be using the dis module, which supports the analysis of C Python bytecode by disassembling it. We call this function and pass the parameter 10 to it. It's going to output the value of the 10th term in the Fibonacci series. So when we execute this program, when the interpreter wants to execute this fib underscore function, it reads instructions one at a time and does what these instructions tell it to do. It looks at the first instruction and grabs the parameter n from wherever the parameters are held and pushes it onto the interpreter's stack. On reading the next instruction, load underscore constant 1, it grabs the next constant number, which happens to be 2, and pushes it onto the stack. Now, this goes on till the code is interpreted by the Python virtual machine and the output is displayed. So if we look at the output, we'll see that at the end of the execution, it gives the value 55, which is the 10th term of the Fibonacci series. We'll now look at different types of errors in Python. We begin with syntax errors, which are the most basic type of errors in Python, and they occur when the interpreter cannot understand the line of code. The most common type of syntax errors occur with the misspelling, missing, or misusing of Python keywords, missing parentheses or quotation marks. There could be a wrong indentation or an identifier name is not correctly written. We'll now look at an example for some common syntax errors. We try to execute this program which has an input statement and it gives us a name error. That's because the input statement has a small I. Now, when we input a name and now we've written print with a capital P, so it gives us an error. We try to execute this. It says hello is not defined. So we need to put that in quotes and we try and execute this program. It will say enter your name and then it says hello dear. We look at another example where we have a while loop, and in the while loop, we have missed out the colon. So if we try and execute this, it will give us a syntax error, invalid syntax. So we put a colon after while play, and then we try to execute, again it gives an error for indentation. So we need to put an indent after the if statement. And now when we try and input Q here and execute this program, we'll see that now it does not give any errors and the program gets executed. Another kind of errors are runtime errors, and a program which has a runtime error is passed by the interpreter because it does not have a syntax error. However, when the program starts execution, one of the statements raises an error, and this causes the interpreter to display an error message. Let's look at some examples of runtime errors. We begin with an example where in this program we take an input from the user for two numbers and we divide the first number by the second number and output the quotient. We'll input 50 as our first number, 10 as the second number. When we execute this, we get the quotient as 5. In case we change the input to 0 for the second number, and now when we execute this program, it gives us an error, zero division error. That means that we cannot have a number divided by 0. We look at another example where we have a list of numbers stored in the variable list1, and we're using a for loop to print each item from the list. In case we make a mistake in the name of the variable, we'll see that it gives us name error, which is list1 is not defined. In case we correct this to the name with a capital L, we'll see that now it will output the numbers from the list. Another very common error is file not found error. And we'll see this example where we open a file, test file, and we write something to this file and close it. When we're going to read the file, notice that the name that was specified when we wrote the file is different from the one where we are trying to open it to read. So when we execute this program, it's going to give us file not found error, no such file or directory. Now, in case we change the name to the correct one, we'll see that now it will give us the correct output from that file. We look at another example where we've imported two libraries, math and statistics, and we've used these two libraries to calculate the square root and the standard deviation. When we execute this, it will give us module not found error, no module named statistics. That means that although the name is correct, it has to start with the small letter S. So when we execute it now, we'll see that it's giving us the correct output. Logical errors are different from syntax errors and runtime errors. And in this case, there may not be any error message. However, the output may not be what you expect the output to be. Let's look at an example. We're going to look at two codes. The first one takes two user inputs for numbers, which are floating point numbers, and finds the average of these two numbers. And the second one finds the sum of the first 10 natural numbers. When we execute this, we are going to first input the two numbers 2 and 4, and the average of these two should be 6 upon 2, that is 3. When we execute this, we'll find that it gives us an average 4, which is wrong, and it also gives the sum of the first 10 natural numbers as 45. Let's re-look at the program. What the error is that we are dividing B by 2 and then adding it to A, but we should add the numbers first. So we put them in parentheses and then divide it by 2. And in the second code, we should start the range from the number 1, which is the first natural number. And because the range goes to 1 less than the last number, we should keep the last number as 11. Let's execute these codes once again, and we'll see now the average of the two numbers is 3, and the sum of the first 10 numbers is 55. We'll now look at some examples of how errors can be handled in Python. Exceptions can be handled in many ways. The first example we are going to look at is a function binary underscore search, and it takes a list and a value that's going to be searched in this list using binary search. We also put in the program a value error using the keyword raise, and we say if the value is not in this list, it's going to raise the value error. When we execute this, it will raise value error and give us value is not in the list. Another common way of handling exceptions is using try and except clause. And these can be put anywhere where we expect an exception or an error to take place. In this code, we start by opening a file in the write mode and writing a string to it. We close this file. We use the try clause, and in that clause, we are going to open this file again in the read mode. And once we've read it, we close the file. And we're going to also raise an exception in case the file does not open. We say except print check the name and location of the file. So when we execute this, it gives us this error because the name of the file is wrong. So if we change this to the correct name, and now when we execute, the try clause will have worked. So in case there's an error, the except clause will come into action. Otherwise, the statements in the try clause will take place. We're going to look at another example where we're going to use the try and except clauses within a while loop. So this will take an input for a number, and in case there's no valid input, it's going to continue giving an error message till the user inputs a valid number. So in the input, we first start by giving alphabets instead of numbers, and then we give a correct number. When we execute this, we'll see that for the first input, it raises an error. And in the second case, it does not raise an error and gives the output. We now look at an example where we're going to handle two exceptions. The first one is the value error, and the second one is zero division error. We start with the try clause where we're taking two numbers as input from the user. In case the numbers are valid, it's not going to give any error and it's going to give us the quotient. In case the numbers are not valid, it will raise value error exception and give the output as the dividend and divisor should be numbers. In case the second number is 0, it will give us the zero division error and print the divisor cannot be 0. Let's start the input as the first one is number 23 and the second one is two alphabets. So when we execute this, it's going to give us the dividend and divisor should be numbers. In case we change the second number to 0 and we execute this, it will give us the error the divisor cannot be 0. So that was a little bit about executing a program and debugging it. I hope you understood. You can always click on the links in the description and use those in your practical file. Do keep watching and subscribe.